Hi everyone, just wanted to take a little bit to talk about absolute value inequalities. And you'll be happy to know that absolute value inequalities are relatively straightforward. The toughest part is remembering which compound inequality you rewrite them as. And as long as you can solve compound inequalities, it shouldn't be anything new. So let's start down here at this chart just to talk about which absolute value inequality will break into which compound inequality. Now, we're looking at first the situation where the absolute value of x is greater than k. So if you think about it, if x is greater than k, you know it has to be something, bigger than k inside, right? Or something um, less than negative k. So we end up in a situation where we're greater than or we're less than. So we're dealing with an or, right? Um, because think about it, if k was 2, we could put in 2, 3, 4, 5, 6, that would work. Or we could put in, -3, -4, -5, because when we're taking the absolute value, that ends up bigger. All right. So we know that the absolute value of k is the same thing as x is greater than k, or x is less than negative k. Okay. So when we're dealing with absolute value of x is less than k, well, we're going to essentially end up with the opposite of that, right? We know that if x is less than k, that's going to work. So let's say k was 2 again. You could put in 1, you could put in 0, you could put in -1. But the problem is once you get to -2, then when we take the absolute value, we end up bigger again, right? We start going back the other way. So we only have a small region. So we're going to end up with an and. So we get that x is between k and negative k. So this is our and. So we know when we have a greater than, it is an or, great or. So just a quick little way to remember that. And less than, and. And as it turns out, greater than or equal to, if you go through that same logic, is again going to be an or. So we get x is greater than or equal to k, or x is less than or equal to k. And then finally, same thing with less than or equal to, we're going to end up in between less the region. Okay. So the good news about this, is you'll notice that whenever we're starting with a less than or a greater than, we have only less thans and greater thans. And when we have a greater than or equal to or less than or equal to, we are dealing only with less than or equal to's or greater than or equal to's. So there's no mixing and matching. So let's look at the top. Now we actually have to go about solving one of these. First thing that you are always going to do, as always, isolate the absolute value. You want absolute value by itself. So you get the absolute value is either greater than, less than, greater than or equal to, or less than or equal to something else. So subtract the 3, minus 3. I get the absolute value of x minus 6 is less than 2. Okay, so that ultimately means I have to break this up. It is a less than, so we're going to do the region in between. So when I break it up, it ends up being absolute value. We get rid of the absolute value. It's less than 2, but it has to be greater than -2. Now we're just going to solve this the way we would solve any other and compound inequality. So what I'm going to do, add 6 to all sides, because again, you can do it this way. If you would have rathered, you could have rewritten it like this, and then done the and done 8x minus 6 is less than 2. That's fine as well, and could have done it this way. I'm just going to do it all in one go. So that should be 4. It's less than 8x, which is less than 8. And I divide by the 8, everything by the 8. So I get 4 over 8, which is 1/2, which is less than x, which is less than 1. So if I graph that, I'm going to be super lazy with my graph. 0, 1/2, 1. Okay. We luckily have open circles at both of, oh, that's an open circle. It's a horrible open circle, but it is an open circle. And then we are just doing the in-between region. Now, if you did that in interval notation, we know we're going from 1/2 up to 1. Okay, so we know that x is an element of that in interval notation. All right, now let's look at the other scenario. Once again, we have to make sure to deal with isolating first. So let's subtract the 8. Subtract the 8. So I get 3 times the absolute value of negative 8x less than or is greater than or equal to 72. All right. When you divide by 3, you get the absolute value of negative 8x. It's greater than or equal to 24. All right. So now it's a greater than. So we have either negative 8x is greater than or equal to 24, or negative 8x is less than or equal to negative 24. Okay. So then we need to divide by the negative 8. The other nice thing about these particular problems, you'll notice that whatever you're doing on one side, you're doing to the other one. So it should be relatively easy to keep track of. We just divided by a negative, so we have to remember to flip the inequality. And then that would be negative 3. So x is less than or equal to negative 3. Or, again, we're going to divide by the negative 8, so we are going to flip the inequality again. I get x is greater than or equal to 3. The other nice thing about this is when you go through these, because of the way the absolute values are written and the way that we will actually see later on when we are graphing absolute values, there's a degree of symmetry. So see how we're dealing with negative 3 and 3. Here we kind of were centered around 3/4. So there's some symmetry that you'll see later on when we graph, but there should be a degree of symmetry when you solve these. Okay, so now we're going to graph it on a number line. I'm going to do 0, 3, negative 3. Okay, so we are less than negative 3, greater than 3. And I'm using my closed circles because they are less than or equal to and greater than or equal to. And then finally, my interval notation, I've run out of room over there, so let me just do it over here. So again, if I look at the left-hand side, I go from negative infinity up to and including negative 3. So I go from negative infinity to negative 3, and I have to include that because I am using a closed circle. And that is in union with the other side, which goes from 3, including 3, up to up forever. So I go from 3 off to infinity. Okay, and that's how I would write that using interval notation. So these are the solution sets for the absolute value inequalities. Okay, so I hope that helps. Really, once again, the same thing as we had been doing with the compound inequalities. The only difficult thing is you need to remember which one it breaks into, great or. So if you have the great or somehow in there, it's going to be an or, and then less than and. All right, so have a great day.